We're ready to begin the electric outboard motor conversion since we determined that the shape of the overhanging hull and transom and a large lazarette locker are suitable. We're going to install an E-Propulsion Navy Evo 6.0 6 kilowatt 48 volt motor with regeneration ability to charge the batteries when under sail. We'll also have a Tohatsu 9.8 gas motor that will fit here either as a backup in case the electrics failed or as an alternative to extend the range if the owner decided he wanted to make an extended trip on the ICW, for example. Here is the Tohatsu 9.8 gas motor and the E-Propulsion Navy Evo 6.0 electric motor. They're both long shaft, high thrust props. When the motors are tilted up, the gas motor tilts up to about 80 degrees, but the electric motor only tilts up to 60 degrees where the catch engages. Now it will tilt all the way up to 90, but it doesn't have a latch to hold it there. So on the boat, the bottom of the motor would probably slightly drag the water when it's tilted up at 60 degrees, so we'll have to use a rope tackle to make sure it stays up all the way to 90 or close to it. Here, when they're tilted up, you can see the difference in the size of the top of the motors. We're doing a bench test of the E-Propulsion 6 kilowatt motor. This is the E175 48 volt lithium battery. So we're just making sure that all of our connections are correct and our cabling is right and that there's no faults. So we made up a sketch here of the wiring diagram. We've got the throttle, the display, the disconnects. That's the battery charger for shore power and a disconnect. And we're just running it now at low RPM. So we've got 6,000 watts available. We're only up to 600 here. So we've cut the communication cable and soldering on a connector so that it can be removed when the motor is taken in and out. To begin, we laid some scrap plywood inside the locker where our measurements indicated the motor shaft cutout will go, and we epoxied them together with plastic sheet underneath them to prevent it sticking to the hull. So we'll pull this mock-up out and test the fit on both motors before cutting the hull in order to confirm the location and shape. So that will represent back at home the exact shape of the hull and transom. We've got the mock-up secured here now around the motor, and that represents what the shape of the hull is and the transom and where the motor mount board goes. And I've made a sketch of the dimensions that I need to transfer to the boat. And we've got a 1/2 inch spacer block here that we'll use for leveling on the final assembly to make sure everything lines up properly. There's a lot of engine related and other things we have to clear out of these cockpit lockers. Got to empty out all this electrical and plumbing. And all of these hoses. We're removing the binnacle and converting to tiller steering for several reasons. The binnacle takes up too much space in the cockpit, and its complicated mass of cables, wires, gears and pulleys, chain, brackets, it's more prone to failure. And a binnacle requires more complex and expensive autopilot than a tiller does. The wheel's also less intuitive feel when steering and doesn't give you the natural feedback of weather helm, and with a tiller you see instantly the rudder angle. The boat is in port 90% of the time, and a tiller will swing up out of the way to clear the cockpit, and it also simplifies connection to wind vane self-steering. Removing the binnacle is turning into an all-day job, because first we've had to get the water heater out, which was there, and it was an inch too big to fit out the hatch opening, so it had to be stripped apart piece by piece down here. And then all the cables running from the binnacle and to the quadrant were not very accessible. They came out. And then the engine throttle and shifter ran through all the brackets. So before the binnacle can come out, those have to be removed. And they can't be accessed easily, so it's a struggle every step of the way. And here you can just see why I could never live with a inboard diesel in my boat. And a bonus will be to get this massive diesel fuel tank out of this locker. It's also sitting up quite high under the deck here. We checked our position for the hull cutout pattern according to our sketch, and that turns out to be 13.5 inches aft from the bulkhead position, which is going to be here, to the motor mount, and another 3 inches from the aft end of the motor mount to the forward end of the hull cutout. And then we will start by drilling a 2¼ inch hole at the top to get a round corner and a place to start the saw blade. We set up some 2x4 bracing temporarily to test fit the gas motor. And we've got the tiller strap put in place down here to show how much clearance we need to get this off and on with the bulkhead that's going to go here. And so that just fits when it's tilted up. And the cutout in the hull and transom looks pretty good the way it is. Now I'm going to tilt it down. And we have plenty of room at the transom back here. And now we're going to check for side thrust clearance to position our vertical panels that support this motor mount board. Everything fits good. Making a mock-up of the tiller we're going to have to build. And this is the 45-degree position right there before it touches anything. And if you need a little more, you can just lift it up a little. We fit the two side panels that support the gas tank shelves and the motor mount board, and I've written how long we want the fiberglass cut and labeled it so we know where to put it. And For some areas where we need flexible, we're using 6-inch 10-ounce fiberglass tape, and for most of the other areas we're cutting our own 1208 fiberglass cloth, which has cloth on this side and a matte backing on the other side, similar to the common 1708, but slightly lighter, a little more flexible. We started putting this together after we glassed in these 3 panels. We made a forward center buoyancy chamber here, and to make these panels we start with a cardboard pattern and then we trace that onto plywood. And we're putting in drainage tubes. We have to fiberglass those in on each side, and then we'll have holes through the hull above the water line to drain the cockpit out, because later we're going to reverse slope the cockpit floor so it drains aft and eliminate those forward seacocks. And under here we have the rudder shaft support beam painted and back in place with its block and bearing on the shaft. And for the quadrant we decided not to use those cables because they were binding, so we're going to fiberglass in wood blocks as rudder stops with the fiberglass plate on top so that the boards can't split. Got the aft end of the cockpit floor in place and the gas tank shelf and cleats to hold the tanks. Here's a demonstration of the boat turning on its own boat length with the side thrust. Tiller over, motor over. Fully maneuverable. We're hauling out here at Two-Way Boat Yard near Brunswick and Darien, Georgia. We have to replace some seacocks, close some holes below the waterline, and carry on with the refit. Yesterday we motored 17 miles here from the other marina down the rivers and had a good first test of the 9.8 Tohatsu motor and found the boat does really well. 5 1/4 knots at full throttle. Got about half a gallon per hour, and that comes out to about 10 miles per gallon as expected. Now we've got to remove this 450 pounds of Perkins 4108 diesel. To wrangle this motor out the hatch, we need to lift it up off of its beds and then slide it forward to get it under the hatch. And Mark's going to use his ample weight on the other end of this beam. Now we've pulled it forward under the hatch and set it down so that we can access the back of the engine, try to get that transmission and some of these other brackets off, get the bulk and the weight down before we try to go up through the hatch. Got it all trussed up and using come-along staggered to get enough lift to get this out. Halyards supporting the midpoint of the boom and safety lines. prop aperture in the rudder and the hull. Shaping these wood blocks. This one's held in with a couple of screws until we can fiberglass it. We've applied a sandable fairing compound on top of the fiberglass. And now we are using this sander, as well as occasional checks with the longboard to look for high and low spots. Now we've filled in the rudder, and you can see without that big hole there, it'll be a bit more effective on steering. Now that we have a good forecast, dry weather for several days, we're going to cut out the cockpit floor and angle it down aft to eliminate these seacocks up here and gain some headroom. Here we've laid in a cardboard pattern for cutting out a new footwell floor. Decided we couldn't use the old balsa cord one, so we're going to make a new one with plywood covered with fiberglass. We've added a watertight bulkhead here that is going to have a gasketed door on it for maintenance access, and then this whole section around the rudder shaft is going to be in a watertight locker, isolated from all other lockers, so that if you ever had a leak there, it wouldn't go into the bilge and sink the boat. It would be contained there, and you could wait until it was convenient to repair it. Here's the 3/4 plywood. The top of it has 2 layers of 1208 fiberglass on it. Got the footwell floor glassed in now. Here it is with most of the panels in place. There's the drainage on each side for the cockpit footwell, and good clearance for the rudder head fitting. Glassed in some supports between the deck and the transom, and got the framing in for the hatch. Making a cardboard pattern for the upper sliding cover boards. Made cardboard patterns for transferring to this 1/2-inch Davini cell for the separate sliding boards to fit the electric motor. And we've rigged up hoisting tackle, which works good to make it easy to hoist the motor up for sailing. And we're running the cables towards the battery. We just received 200 pounds of lead ballast. We have 3 25-pound bags of lead shot, and the other 125 pounds are in 5-pound ingots. And this is to replace some of the weight that we are losing from taking out the inboard engine, the binnacle wheel steering, a hot water heater, fuel tank, all the rest. And that was about 850 pounds we took out, and we'll be putting back in about 650. So to keep the boat trimmed, which is important also here because we don't want the stern higher than normal, so that we can keep the outboard motor prop submerged. So to make up the difference, we'll put about 200 pounds of lead low and aft in the bilge. We've got the lead ingots placed in the bottom aft area of the bilge. You can see that raised section of the bilge is where the original lead ballast stops. And then we're coming up vertically, and we're going to pour in lead shot and then fiberglass over it all. I've mapped out where I want all of the electrical components and bus bars, shunts, meters, etc., so that we can run the electric motor cables. And we've got the gasket on the aft watertight compartment sealing off the rudder shaft, and we've got its drain fitting installed. So we're ready to close that up. So aft of the cockpit lockers, under the gas tank shelves, are the fiberglass tubes, where I glassed over PVC tubes to take the cockpit drains out through the hull near the transom. And then that locker gets sealed behind this Bexon 6-inch deck plate. Here's the 48-volt battery, and there's the 12-volt. And here we have a huge storage locker in front of them, and there's going to be a cover board here to protect things that are stored here from tumbling into the batteries. And there's a secondary longer-term storage compartment under here in this section. And then below that, this will come out for aft bilge access. And there's the added ballast we put in. And the drain hoses here and here for the cockpit lockers. And here we're starting to put in the wiring, all the bus bars. The 48-volt wiring is in. Here's the completed tiller conversion. We've got the outboard motor well completed, except for final painting. This has two positions there if you just need quick access or when motoring a long time. Otherwise, hook it here for better access. Front door drops down for access. Here it shows the cover boards in place. The motor normally rests on the lower cover boards so that there's not load on this hoisting tackle, but then when you want to deploy the motor, you need to pull it up fully, engage it here on that cam cleat, and then you are able to pull out the bottom cover board and it's held on with a lanyard so it doesn't disappear overboard. Then to use the motor, over here is the throttle. Put it in forward. You can barely hear it running. Up here is the display showing how many watts is being used and the RPM. And of course we have side thrust available by turning